Recording in progress.
Okay, let's start. Okay. Let's talk about Riemann sum. We learned about Riemann sum before. The first time we see Riemann sum, those questions are very simple. For example, if I ask you to use a Riemann sum to calculate the area under this curve, I say, can you please calculate the area from 0 to 5 under these brown lines? You can split this into 5 equal pieces. Each set is 1, okay? And if you choose the left Riemann sum, you will calculate those right angle area. If you choose the right Riemann sum, you will do this way. If you choose the midpoint Riemann sum, you're going to do like this, okay? But none of them is going to give you the accurate values because doesn't matter which way you go, you missed some other information. You either over predict or under predict, okay? Not exactly solution. So today we will talk about how do we use Riemann sum to get the exactly value. So we have to combine the concept with limit that we have learned a long time ago. When we do Riemann sum, if you make the subinterval to be just a limited number, it's going to not be exactly the same solution. So for example, you have the y equals to x squared plus 1. This is x squared plus 1. When x is 0, it's 1. When x is 1, it's 2. When x is 2, y is 5. When this is 3, this is going to up to 10. And then when it's 4, it's going to go to 17. If you want to get the area, as long as you make your number of sub into small pieces, if you cut this into infinity, many small pieces, those small areas bounded by this is going to be exactly equals to the area under this. So let's use the concept of limit to work on this, okay? So Aiden, let's do this one, first one together.
Okay.
When we do the conversion between the integral, you have this function and you have the lower bound and the upper bound, okay? And you do this, that means you are calculating the exactly area between 0 to 4 under this curve.
Okay.
If we want to change this to the Riemann sum, we have to know first, number 1, delta x equals to how much?
I guess it's like 4 minus 0, so just 4 over n.
Okay. 4 minus 0 divided by n. That is 4 over n. Next step, what do we do? We can express xk, okay? How do we express xk?
I think it's equal to 0 plus k times 4 over n, or k times, I guess, change in x, which is 4 over n.
So xk is going to starting from the lower limit. If it's 0, it's 0. If it's not 0, it's going to be a, okay? And then a plus k times delta x. K is a subinterval. for this one, k is 0. For this one, k is 1. For this one, k is 2. For this one, k is 3. Continue going on. Okay, so k is an integer starting from 0. Make sense?
Okay, yeah.
Yeah. K is between 0. You can say starting from 0 then to up to n minus 1. If you're starting from 1, then you go to up to n. Okay.
Okay.
So k is between n and 1 and n, and it's an integer. And then we are going to express our f of xk. Here, this is a function. We are going to plug in this into here.
Okay.
This becomes 0. Let's continue.
So change in x is equal to 4 over n.
Mm-hmm.
So xk is equal to 4k over n.
Mm-hmm.
Then plugging that in for x, you get
Sure.
4k over n squared plus 1.
So this becomes to 4 over n because a is 0, so we don't need to worry about it.
Yeah.
We do this guy plus 1, correct? So this is 16.
Wait, isn't there supposed to be
over
a
k, sorry.
Yeah.
Over k. N is the total number. So 16 over k squared plus 1. And then the last step, we are going to change this to the limits format. Okay?
Okay.
So we are going to do limit. We have to keep this habit. We want to, by the time when we make it to be infinite subintervals, it's going to be exactly equals. So we make the n equals to infinity. Okay?
Wait, isn't it supposed to be 4k over n squared?
Oh, sorry. I have a typo, sorry. Yeah, because one student does not join the class and keep reminding her. Okay, so we get this guy. We need to, each time changing from integral to the limits format, we write down limit and then write down sigma, okay? And then this is from k equals to 1 up to n. And then we copy down the full of fxk. But we have to keep in mind, we need to times the delta x, which is 4 over n. So say this one more time. That guy is, this guy is this function. This dx represent 4 over n, correct?
Yeah.
And then this sigma means integral. If and only if the n go to infinity. That thing is this thing. The time you can write down the sigma to this integral when you put n go to infinity, okay? If n is like saying n is from 1 to 4, then this guy does not equal this guy, okay? This guy will equal, these two guys will equal if and only if when n is approaching to infinity, okay? Does this make sense?
I think so, yeah.
Okay, now, yeah, let me see if you can do the second one correct by yourself, okay?
Okay.
Yeah, see the question is this one, okay? That's the answer for other questions. They list there to let you do the matching game. So let's do our own work. Look at this. This is a definite integral. So how do we get dx again?
You do 7 minus 3 over n.
So you do 7 minus 3 over n. This equals to 4 over n. Next step.
I think I forgot the next step. What was it again?
Let's put the apple to
Oh, right.
apple.
Yeah. XK, right?
Yes, xk
Okay.
equals,
This case it's a plus k times 4 over n. I think a is
sure. So a is
3.
who?
Yeah, a is 3 because that's your initial value.
Mm-hmm. And then k times
yeah,
who?
4n.
4 over
sorry.
n.
Yeah.
Some textbook, they don't use k, they use I. It's the same, okay? It's the same. It's just a subinterval number. It's an index number, just like those sequence in the series, you know.
Yeah, okay.
So next step, who is our fk? What's the function?
Oh, the function is x squared minus 8.
So we are going to plug in this, okay?
Yeah.
Go ahead.
So that just becomes 3 plus k times 4 over n
Squared minus 8.
Yeah.
Now let's use the completing the square. Go ahead, please.
Completing the square. Okay. Let's see. So
3 squared is 9.
oh, yeah, and then it's like plus 24 over n times k, and then plus 16 over n squared times k squared, and then minus 8 at the end.
Okay. One more step.
Simplifying it, it's just 16k squared over n squared plus 24k over n plus 1.
Okay. So how do we write down the limit format? Do you remember the big part? That's a big part, big package.
I think it's like limit n approaches infinity.
So it's limit n approach to infinity, and then you do sigma, and you say k is from 1 to what?
N, right?
Okay, and then you copy down the whole thing.
And then you times change in x at the end.
Okay. Very good. So it looks a little bit complicated, but the question is not so that hard, right?
Yeah.
Okay. And you will find your matching pattern somewhere. Okay. Yeah. You're going to right here. That guy is right here.
Okay.
Now, Aiden, I let you do one more. Okay. We are going to do the opposite directions. Let's see from the opposite directions. This guy over here. We are looking for this guy's integral format. So given the limits, we want to get the integral format. So who is this guy?
That's change in x.
That is delta x.
Yeah.
Equals to 2 over n. So can I say b minus a equals to 2?
Yeah.
So that means b minus a equals to 2. Look at here. This is the inner one, right?
Yeah.
And who is this? This is your xk, correct?
Yeah.
This guy is a xk. So this guy is 2 over n times k. Yes?
Yeah.
Does this guy plus any number? Plus a 0, yes?
Yeah, plus 0.
Plus a 0. So
Let's
that
see,
means
A.
your A equals to 0,
0, yeah, okay.
correct?
Yeah.
And your B equals
B is equal to 2.
B equals to 2. And what is that function?
That's f of xk, right? Or I guess that's the function.
Yeah, so fxk is equals to 2 over n. So we already have xk, so we can say xk cubed plus 3. Make sense?
Yeah.
So the integral means you have your lower bound 0,
0
you have
to
your
2.
upper bound 2, and your function is x cubed plus 3 and then dx. Okay?
Okay.
Yeah. So doing both directions, we have to do it very well. Yeah, I think you already mastered this. Let me call the next student. Very good.
Okay.
Next one, Emily. Let's see this one. Look at here. Go ahead. First, I leave the step on the left side. Follow the same procedure, please.
So delta x is still 2 over n.
Third x equals to 2 over n. That is b minus a over n. Okay? Next.
Going to xk?
Can we find?
Or
Let's see here. The key point is looking for your xk. That guy is your xk. Okay? Make sense? Yeah. That is xk. Okay? So who is the a? I write down here. Xk is a plus
k delta x?
delta x. So who is a?
A plus 2 over n times k.
So a equals how much?
Xk minus k delta x?
So a equals to 3, correct?
3?
Yeah, you see?
Oh,
You see that?
yeah.
Is 3. This is delta x. This is k. Yes?
Yeah.
So if you feel this not clear enough, you can say, hey, I'm going to do this. I'm going to do 2 over n and plug in and put k and plus a. So who is my a? A is 3. Make sense now? Now you found this is your xk. Who is your function? Fx is who? Fx is who?
X plus 1? Square root of x plus 1.
Yes. Square root of x plus 1. So the integral is going to be?
From
A is 3, right?
yeah,
So b equals
5.
5. Go ahead.
3 to 5, and then square root of x plus 1 times dx.
Does this make sense now?
Yeah.
Some people feel a little bit confused. Some people argue this with me. Some people say, look, teacher, you put 3 here, you put 1 here. If I take out this, if I say this is plus 4, can I? Yes, if you want to do that way, totally fine. So if you say limit, copy down this. If you say, I want to say this guy is 2 over nk plus 3 plus 1, so that's plus 4. And then 2 over n. Then who is my a? This means a is 0, correct? Yes. Emily, this a is 0, yes?
Yeah.
A is 0. B is how much? 4, correct?
Yeah.
Hold on. No, B is 2, yes? From 0 to 2.
Oh, yeah.
And then I'm going to do this guy integral. I say, is this guy as from 0 to 2, and then square root of x plus 4 dx, correct?
Mhm.
Yeah, you see, teacher, why I get 2 different answers? This value is going to be the same when you do a U sub. Let's do a U sub. We already learned the U sub last week. Let's see, I'm going to make U equals to x plus 3, can I? Yes.
Yeah.
And the du equals to dx, right?
Yeah.
When x equals to 0, u equals to 3. When x equals to 0, 2, u equals how much?
5.
So isn't that same as 3 to 5? And then u plus 1 du. Is this 2 exactly the same?
Yeah.
So doesn't matter which one you choose, it should be the same answer, okay? But
Mhm.
in your school, a teacher might be nice, they on purpose put a parenthesis. They on purpose put a parenthesis. So the guy inside this parenthesis, they explicitly show you the a value. You are looking for that guy to tell which one is your a. This guy is single by itself, so the a is 0. This guy has a equals to 3. Okay? Does this make sense?
Yeah.
But this one, unlucky. You cannot tell from here, right? Yeah. Sometimes, oh, sorry, I'm saying this one. From here, because this guy is already put into this format. So you don't know who is your a value. From this expression, you cannot really tell your a value. What you can do, you have to first do completing the square. If you want to do this direction, back to that direction, what you have to do is you have to do completing the square first. So let's do this, do the opposite direction. Let me call the next student. Olivia. Let's try from this way to that, okay? Look at here. Look at here. We want to work this very well for both directions. So if we were given this, let's completing the square first. So we can write down 16k squared over n squared plus 24k over n plus 1. Let's go. Continue, please. Who is this guy?
Wait.
This guy is who? 4k over n squared.
Yeah.
Correct.
Mhm.
And then plus 2 times. Remember, we use this formula starting from order 1. This is this, yes?
Yeah.
So the first guy, we're looking for the completed square format. And then that one, can we see this using 1? I don't think they match. So we want to honor here. So I'm going to do 2 times. I copy down here. Okay, and then times 4. This is 6 over n times who, Olivia?
Wait, it's not 8.
2 times 4 is 6. 6 times 4 is 24, yes?
Oh,
Correct?
yeah.
This 2 equal. You want to make this 2 equal to find out the completed square number, yeah?
Yeah.
Okay, so times 4, because, wait, hold on. Yeah,
Isn't it 3.
sorry. This is 3. Make sense?
Yeah.
And then the guy square is going to be the next term, yes?
Yeah.
Because we do a plus 3 square, we have to minus the 3 square and then copy 1, yes?
Yes.
This is a matching term. This is a matching term. This is a matching term, and that's the guy we are looking for, correct?
Mhm.
Okay. This equals, go ahead, tell me, this equals to what?
4k over n
Plus 3 square. How much is this?
minus 8.
Now, when we have here, we know the b over a, and b minus a over n equals to 4 over n, correct?
Yeah.
And our xk equals to 4 over n times k plus a. So look at here. This tells us a equals,
3.
b equals,
7.
7. Then let's write down the integral format from 3 to 7. And what else?
X squared minus 8.
There you go. But we have to put dx, okay? Because this dx is that delta x. That delta x is this 4 over n. And this x squared minus 3. Oh, hold on. Minus 8. This is x squared minus 8. I have a typo. This is my x squared. Yes?
Yeah.
Makes sense now? So this is one of the most complicated questions. They give you a this and they want you to write down this direction. When we see this, students feel panic because you cannot find out where is the a. You do know that b minus a is 4, but look, from here, you cannot find out who is a. Then you will not be able to find out who is b. You don't know a, you don't know b, you won't be able to fix here, and you feel nervous. Don't worry, when you see this, you want to do the completing square, okay? Make sense?
Yeah.
Any other people have question for this one? Given this limit sigma format for the Riemann sum, you want to write down your integral format. We need to be able to do both directions, okay? Both directions. We have to do it very well. If you have any question, please stop me. Next one. Let's see here. All right, Zijun, let's try this together. Our step one is find out delta x. Who is delta x? This one,
Over n.
2 over n. This also equals to b minus a over n, okay?
Okay.
And look at this format. This is 2 over n times k. From this parenthesis, and you can tell who is this.
Is that the A?
Yes, very good. And you learn things very fast. A equals 3, so B equals, look,
Oh, 5.
there you go. So now can you tell me who is the fx? Who is the fx? Fx equals to who? Fx
here.
is that guy. This is your x, and this is the y. So x plus 1. Does this make sense?
Yeah.
Let me write down one more step for you, okay? Xk equals to a plus delta x times k. Or you can say 2 over n times k plus 3. Yes?
Mm-hmm.
Okay, so that is your x. That is your x. This is gone, x plus 1, right?
Yeah.
And then let's say it. Say integral. Definite integral from where to where?
3 to 5.
From 3 to 5, and then fx is x plus 1, and then dx. Make sense?
Yeah.
Okay. Feel better about this question now?
Mm-hmm.
Okay. Now, Zhao Yuchen, let's do this one. Let's see here, okay? I leave the left one as your first apple. Let's start. Go ahead.
Delta x
Equals
2 over n
equals b minus a over n, yes? And from that guy, this does not have anybody inside plus something, so we can tell a equals
Theorem.
good. B equals
2
equal. So xk, let's write down xk. Xk equals to 2 over n times k. So fx equals to who? This is x. Okay, this is x. So what's this function called? X squared plus 3. Correct. Now, this whole thing can be replaced by this, correct?
Yeah.
Okay. So we say this is integral from where to where?
2 to 0.
From 0 to 2.
Oh, okay.
And then do x squared plus 3 dx. Make sense now?
Mm-hmm.
All right. Now let's do a sine. The graph here are showing you this. They show you the function is this. Okay. Now Aiden, let's do this. Let's see how much is our delta x. Now we want to express this one. They didn't show this, but everybody has to know how to write down the area under this curve from 0 to pi over 2. That's your function y. So you put here, okay? Now let's go ahead.
Okay. Wait, sorry, so what am I supposed to be doing again?
We want to change this to the limit format.
Oh, okay. So you start with change in x, right?
Uh-huh.
So change in x is going to be pi over 2 minus 0 over n. So it's
Sure.
just pi over 2n.
2n. Correct?
Yeah.
Okay. Now xk equals?
Xk is equal to 0 plus k change in x.
Mm-hmm.
So in this case, it's just k pi over 2n.
Very good. Now go ahead, tell me the long package.
So that's going to be, you do f. Oh, right. Okay. You can do
Yes.
limit n approaches infinity. Then it's like n over sigma.
Hey, we put sigma first.
Oh, right. And then you put 1 on the bottom and n at the top.
What thing put on bottom? What thing put on top?
Should be 1 and then infinity.
Mm-hmm.
Or sorry,
Hold on.
n. Sorry, 1 and n. Sorry.
Now, infinity is outside. Sigma k equals to 1 on bottom, n on top. Okay.
Okay.
And then we put a sign. So will your teacher take off your points if you don't write down this, correct? Yes, your teacher will take off your points. If you put this in front and put this second, your teacher count you as wrong? Yes, it's going to be counted as wrong.
Okay. So then you do, it's sine k pi over n. Because it's
Times 2,
right?
2
Yeah.
and 2 will cancel.
Yeah.
And then times k pi over 2n.
Yeah.
Okay.
Oh, wait.
Makes sense.
Isn't it just change in x? Or is it like, I thought you only multiply by change in x at the end, not xk.
This guy, I times 2 here.
Oh, okay. Wait, never mind then. Sorry, I just messed up.
Okay.
Sorry.
All right, 2 and 2 cancel. So this is k pi over n. And then outside is this, okay? This is inside the sign. This is outside the sign function. Okay,
Okay.
all right. Okay, we haven't done the other direction for a while. Aiden, try one more for here.
Okay. Okay, so for the opposite direction, okay, so it's, wait, doesn't the opposite direction start off with the,
Everything start with this.
Yeah.
Everything
Okay.
start with this.
Wait, so which question am I doing? Am I doing the,
You doing this?
oh, okay. Is that
You're
the
doing
other
this.
direction though? Okay,
Yeah.
sure.
Previously, we have the integral. We do the limits.
Yeah,
Oh no, this is same,
yeah.
not the opposite direction. You're right. Go ahead. Delta
Okay.
x equals.
Yeah, delta x is equal to pi over 2 minus 0 over n. So it's just pi over 2n.
Okay. Next.
Next you have xk is equal to 0 plus k change in x. So it's just equal to k pi over 2n.
Okay. So A is 0, B is, well, doesn't matter. We don't worry about this. Okay. Yeah.
Yeah.
It doesn't matter. We can do the limit format now. Go ahead.
Right, so you do lim n approaches infinity. You write the sigma, and then it's k is equal to 1 on the bottom, n on the top, and then it's cosine 2 times k pi over 2n, so it's just k pi over n. And then you multiply that by k pi over 2n.
There you go. So we don't feel this question hard anymore. Okay.
Yeah.
Yeah. But in your school test, sometimes students still get nervous about doing this question. So we have to practice until we can do it very fast. Okay.
Okay.
Next one. Emily. Let's do the next one. Go ahead.
Delta x equals 7 minus 3 over n.
Okay.
And then xk is equal to 0 plus k times 4 over n. Is it 0?
Who is A?
Oh, -3.
Really?
Is it?
Hold on. This is your A. Students, we get confused by the two format. -3 is not your A. This is your A. The reason you want to see -3 is your A is because you confuse yourself with this. When you are forming the limit sigma format to the integral format, here A is 3. But when you were given an integral, that guy is exactly your lower bound. That's your A. Okay? Make sense? So the question I asked you just now, that guy is not A. No, that guy is your A. Does this make sense?
Yeah.
Okay. It's okay. Sometimes I get confused too, okay? So let's go ahead.
3 plus 4k over n.
Okay. So far, so good?
Yeah.
Go.
And then the limit as x goes to infinity.
E?
Or is it k?
No.
Oh, it's n. Just try all the variables.
You know, when you see people, students, when you see teachers doing this or other people doing this, you say, sounds easy. It's okay. I can do it. When during the test, you say, k go to infinity. And then here, some teacher take half points off if you write down that way. If you write down k equals to infinity, okay? Because the meaning is totally wrong. Continue.
The bottom is k equals 1,
Sure.
and then the top is n.
Mm-hmm. So if we have trouble to remember this, we write it from the inner layer, okay? Because we know the k is the subinterval from 1 to n. K is the subinterval from 1 to n. And then when n approach to infinity, this is going to be exactly the definite integer. Does that work for you?
Mhm.
Okay, next. Put the fxk.
4 times 3 plus 4k over n, which is just k.
And then minus 3, right?
Yeah.
But I have to make sure this covers this, okay? Make sense?
Mhm.
Okay. Equals 12 minus 3 is 9, and then plus 16k over n, okay?
Mhm.
Make sense now?
Yeah.
All right. Now let's do one more. Emily. Hey, Emily, did I call you or no? Yes. Olivia, sorry. Olivia, let's try this one.
Okay. So delta x would be 4 over n. And then xk would be, yeah, it would be just 4k over n.
Because a is 0, okay?
Yeah.
Now continue. It's right there.
So then it'd be the limit as n approaches infinity. And then k equals 1 and n at the top.
Sure. And then
So then it'd be ln
mhm,
4k over n plus 1 and
times,
then times 4 over n.
there you go. Okay, very good. Now, let's do this one. Ziju, let's try this one. We want to change this to the integer format. Let's figure out the delta x first. Who is delta x?
It's 2 over n.
Okay. So xk equals
Xk equals a plus 2. No, x plus 2.
this is our xk. This times k is xk. This times k plus a is xk. Inside here, they didn't plus any number, so the a is 0. Does that
Oh.
make sense?
Yeah.
Okay. So A is 0. Now B equals to how much?
B is 2.
Good. B equals 2. So integral. This whole thing can be replaced by integral. Upper limit is who?
0.
Good. 2. 2. Yes.
Yeah.
And then what do I write down here for the dx? What should I write down here?
X cubed plus 2.
Sure. Make sense now? Make sense to you now?
Mm-hmm.
Now, let's do the last question, okay? Let's see here. This one, okay. Zhao Yuchen. Let's do this together. From this, who is delta x?
I'm sorry.
This is delta x, correct?
嗯
2 over n, which is b minus a divided by n, correct?
嗯
Okay. From here, you can tell this is 2 over n. This is delta x, you see? Delta x times k plus a. So 3 is the a, yes?
yeah.
A is 3. A is 3, b will be how much?
5.
Good. So the lower limit, the lower bound is 3, upper bound is 5. Who is that function? This is x, okay?
嗯
So copy down square root x cubed and then plus 1 and then dx, okay? This is dx. dx times k plus a, that is your xk. xk cubed plus 1, so this is x cubed plus 1. Okay, make
Okay.
sense?
嗯
So students, after we learn this, we will know how powerful calculus is. Doesn't matter how complicated the area, the function is, you can get the exactly area under that curve, okay? Before calculus, doing that is not solvable math questions. Okay, now we are going to do the fundamental theorem of calculus. The name sounds complicated, but the question is really easy. We can take a look, okay? Like Aiden, let's try this one. You have the derivative given here, and your y1 equals 6. They ask you y3. The fundamental theorem of calculus is saying you do y3 minus y1 equals to from 1 to 3 f prime dx. Make sense?
Yeah. I
Okay.
think, okay.
So you have y3 minus y1 equals to from 1 to 3 y prime dx. So let's first do this part, and then we will be able to get y3. Let's go ahead, do this integral first.
Oh,
Go ahead.
okay, like what it's equal to, okay, sure. So it's gonna be 2x.
Mhm. So the antiderivative for that one is you say 2x and then 1, 2, 3. And then who is this guy? Who is this?
Not too
Yep.
sure.
If we have trouble finding out the antiderivative, we always change that to the power format, okay, exponential format. Yes,
Yeah. Oh, yeah.
and we do x to the power -2 plus 1,
Yeah,
and then
divided
we
by
do
negative
the,
1, yeah.
yes, do that guy reciprocal, -1, okay? So this is negative x to the power -1. So minus x to the power -1 from 1 to 3. Make sense?
Yeah, that makes sense.
Okay. This is 2 times 3 minus 1, and then minus 1 over x from 1 to 3. Make sense?
Yeah, makes sense.
All right, continue. This is 2 times 2 is 4, and then minus 1 over 3 minus 1. Make sense?
Yeah.
So this is 5 minus 1 over 3. Okay?
Okay.
Yes, equals
Yes.
y3, we don't know. But y1 we know, it's 6, right?
Yeah.
Okay.
Yes.
Y3 minus y1. So y3 equals to 11 minus 1/3. Make sense now?
Yeah, that makes sense.
Okay. Now let's do next one. Okay. Ethan, you do one more because you missed several classes before. Look at this one. You were given the derivative and you want to find that part. So we do the definite integral from 0 to pi over 4. So we want to find out the antiderivative. Who is that guy's antiderivative?
That dude's antiderivative is 1/2 sine 2x.
Hmm?
Oh wait, no. Wait.
Look,
Yeah.
this guy derivative is cosine 2x times 2x derivative, which is 2, and 2 and the 1/2 canceled, right? So that is correct. And then we do this.
Yeah, it's 1/2 times 1 minus 0.
Which is 1/2.
Yeah.
And then this is pi over 4 minus f of 0. Yes?
Yes.
Okay. So this is f of pi over 4 minus 3. So equals to how much? That equals to
That's gonna equal it's should be 1.
3.5, right?
Oh yeah, it's 1/2
Okay.
plus 3, so it's 3.5, yeah.
All right. Okay. Now let's do next one, number 3. Okay. Emily, let's do number 3. Now the sequence is still the same. They give you f prime x equals this, and they ask you, they give you f0, they ask you f1. So you do from 0 to 1, and then you are going to find out f1 minus f0, correct? Yeah, to do this, look. This is impossible by hand. That's not possible to solve this by hand. So for this question, look, we have a calculator. If it's a calculator version question, Then you say, so easy. Let's do this. Do function. Everybody do it, okay? Open your calculator. But when you do the calculator, you have to make sure in the setting, you make sure you choose the reading mode. For both the TI Inspire or decimals, for doing this part, you have to make sure you are in the reading mode, not in the deep read mode. Otherwise, all the result will be wrong. And you type in here. You choose miscellaneous. And you click this integral. And you put lower limit as 0, upper limit as 1. Okay, and then you do a dx first. Everybody, please type in this in your calculator if you use the decimals. Okay. And then you can do parentheses. You can do this, you can do a cosine. You can do a cosine x. You can do a cosine x cubed. Okay, there you go. Emily, does this make sense to you? Okay, this is calculator's question, so it's going to be very easy. The first semester of calculus, the most difficult part is the antiderivative, solving by hand. If the definite integral solving by calculator, it's not hard at all. Olivia, let's see the next one. Okay, for this one, we were given f prime x is this, f phi is 1, f2, you don't know. So you write down this from phi minus 2, and f phi, you already know, you want to get f2, so you want to get this integral first, right?
Yeah.
So you want to type in, you can go ahead, type in e to the power of negative x squared. Okay, so you got this. And then f phi minus f2. F phi is 1, f2 you don't know. So this is how much? If you know f phi, you already know it's 1, f2 you don't know, so you write down. And this part you already know. So f2 is going to equals to 1 minus this definite integral. Okay. All right. Does this make sense?
Yes.
Okay. Now we come to those typical particle questions. I explained that kind of question before. Particle questions. So Zijun, let's try number 5. Have you started AP Physics already?
Yeah.
Physics 1 or Physics 2?
Physics 1.
So in physics, we learned about this many times. Velocity is whose derivative? Velocity is the position's derivative, yes?
Yeah.
And the position is going to be the antiderivative of velocity. Yes?
Mhm.
Okay. And acceleration is whose derivative? Velocity's derivative. Yes?
What is the A
And
stand for?
A is acceleration.
Oh, okay. Yeah.
Mhm. Yeah, like gravity, you know?
Mhm.
And Vt is going to be integral of at dt. Okay. Now we were given this question. Okay, you can read the question, please.
A particle moving along the x-axis has position x of t at the time t was the velocity of the particle.
Mhm.
V of t equals 5 sin of t squared. At time t equals 6, the particle's position is 4 is 0. Find the position of the particle when t equals 7.
Sure. Previously, when we learned the particle motion several weeks ago, we were given the position, which is st, and then we do the st derivative to find the vt. Now we were given vt, we want to find out the st. So what we do? We know the position at 4 minus the position at 0. This distance change is because of the velocity. So your velocity, do the definite integral from the time, here, hold on, at times equals to 6 equals 7. So I should change the times from 6 to 7. Okay. Does this make sense?
Yes.
And then we do this from 6 to 7, and then we do sine t squared, and then dt. Okay.
Okay.
Yeah, don't worry. Doing this antiderivative is impossible by hand. Some antiderivative is possible by hand. Some of them not possible. So they allow you to use calculator. Okay. If they say from which number to which number use calculator, very possibly that one antiderivative is impossible by hand. So you're welcome to try calculator. And you always know that you can get the value from calculator. And they either give you this or give you this, and then you can plus. But the thing you want to pay attention here is they say a particle moving along the x-axis, okay? So it's going to just go one direction. So you don't worry about the vertical directions. You do x7 equals to x at 6 plus, that's the antiderivative value. If you type in the TR Inspire or decimals, you can get this value. In the second semester, when we learn the polar system integral and parametric function, okay, that those things that we learned in the second semester of pre-calculus, we will do the two-dimensional particle moving question. Right now, 1D, easy. Next semester, 2D, X direction, Y direction, and also those polar systems will be harder. But right now, not hard at all. Number 6 is also similar. Give you a function. You don't need to worry about finding the antiderivative. You just use the calculator to do it. But you can still find this by hand. We learned about this antiderivative. Let me see. Does any student remember who is this? Who is the antiderivative for this one? Anybody? Is there any student who remember this one? We learned this about 2 weeks ago. I can even show you. We learned that thing when we do the antiderivative. I wonder if anybody remember? Nobody remember? Look, we learned that guy here, right here, okay? It is because a to the power x derivative equals to ln a times a to the power x. So a to the power x antiderivative is going to be 1 over ln a times a to the power x plus c. Okay? Does that make sense? Yes? That makes sense?
Yeah.
Okay. Please remember those formulas, okay? All right. We may also have this kind of questions. They give you a graph like here. They give you a curve like that. And the region A here, they give you 1.5, but you need to know if it's under the x-axis, the area will be negative. If it's above the x-axis, it's positive, okay? So look at this. Let's figure out this. They told you from 0 to 6. The total integral is 3.5. So you can split this from 0 to 2 and 2 to 6. Yes?
Yeah.
How much is this? What you should put here?
I think it's like negative 1.5.
Negative 1.5. So you are looking for this one. This is 3.5. So this is 5. Yes?
Yeah.
And what will happen if they ask you do the absolute value? If you do the absolute value, you are going to make this and this. Yes?
Okay.
So it's 1.5 plus 5. Okay?
Okay.
So when we do the, when we will revisit those particle motion problem in the integral part again. At that time, the typical mistake a student have is sometimes they ask you the position. For the position, you do the integral directly. But for the total distance, you have to be very careful. You have to put the absolute value. So the thing here, I talk about that formula. This is a position formula. This is a position formula. For the total distance, for the absolute distance that it travels, you are going to do this way. Okay? Let's keep in mind about these two differences. Why you want to make this is because the total distance. So from your home to school, you traveled this amount. From your school, you go here. And then this is the position change. But the total distance, you have to add up these two. Okay? That's the difference between the position and the total distance. Okay? Now, I'm going to upload. Make sure the notes I posted before master everything I listed there. Okay. That's for today's class. See you next week.
再见，老师。
拜拜。